In this video, we will show special quadrilaterals. We will now define 5 special quadrilaterals and review the important properties of each one. The first one is parallelogram. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Any side of a parallelogram can be its base, and a line segment drawn from a vertex perpendicular to the opposite base is called a height. Now we will show parallelograms properties. Parallelograms have the following properties illustrated in this figure. Opposite sides are parallel, so AB and A parallel to DC, and the same thing BC is parallel to AD. Opposite sides are congruent, so the same thing AB congruent to CD and AD congruent to BC. Opposite angles are also congruent, so angle A is congruent with angle C and angle B congruent to angle D. The sum of the measures of any pair of consecutive angles is 180 degrees. So here the sum of angle A and B, which are consecutive angles, is 180 degrees, and the same thing about B and C. B and C are consecutive angles, so the sum of B and C is 180 degrees, and A and D, and the same thing about D and C. Now, what about the diagonals of parallelograms? A diagonal divides the parallelogram into two congruent triangles. So, look at the left shape here. In this parallelogram, diagonal AC divide the parallelogram into two congruent triangles. So, triangle ADC congruent to triangle ACB. And now move to the right shape. The two diagonals bisect each other. So here we have two diagonals, AC and BD. AC divide BD or bisect BD. So here AE equals EC because BD bisect diagonal AC. So AE equals EC, and the same thing AC bisect diagonal BD into two equals line segments. So BE equals DE.